Hello everyone. So for our deep learning project this spring at UT Austin, we taught a GAN to draw a bat. Not the baseball bat, but the creepy mammal. How about generating this image with AI? We're just kidding. This is not an image generated by our model, but we'll get to that in a while. This is an image generated by DALL-E 2. Before we talk about our model training and the amazing images we generated, we'll start from the beginning. We'll walk you through a general overview of GANs, talk about our dataset and some details about it. We'll then segue into talking about what our model architecture looks like and how we train our model to make it a better artist than us, at least for drawing sketches in less than 20 seconds. And yes, finally we get to the exhibition of the amazing pieces of art that our model creates. Generative modeling is basically an unsupervised learning task in machine learning that involves automatically discovering and learning the regularities or patterns in input data in such a way that the model can be used to generate or output new examples that plausibly could have been drawn from the original dataset. General adversarial networks, popularly called as GANs, are a clever way of training a generative model by framing the problem as a supervised learning problem with two submodels: the generator model that we train to generate new examples, and the discriminator model that tries to classify examples as either real, that's from the dataset, or fake, that means generated. A straightforward example would be how a GAN trained on photographs can generate new photographs that look at least superficially authentic to human observers, having many realistic characteristics. Now, here's the dataset that we used. The Quick Draw dataset, which is a collection of 50 million drawings across 345 categories contributed by players of the game Quick Draw, which is an online game developed by Google that challenges players to draw a picture of an object or an idea and then uses a neural network to guess what the drawings represent. The drawings are captured as time-stamped vectors tagged with metadata including what the player is asked to draw and in which country the player is located. As we can see, that over 15 million players have contributed millions of drawings. Now we have some animations of three categories picked from Quick Draw: a bat, cat and hat. These are different pictures that people scribbled in under 20 seconds. Well, the challenge for Google's network was how good can a model do given a mixture of accurate and not so accurate drawings of objects. Finally, diving into our implementation of what has been ideated so far. The goal is clear: drawing bats, Bruce Wayne's fear factor. We use the Quick Draw API to access the bat images in Python. Our setup consists of 72 by 72 size images which have been compressed from the actual 255 by 255 input size. We use about 96,000 bat doodles and a bat size of 32 to train over 30 epochs. Our network architecture is comprised of a discriminator model and a generator model. The discriminator model takes an example which can be real or generated and predicts a binary class label of real or fake, fake meaning generated. The generator model takes a fixed length random vector as input and generates a sample image. For the generator model, we use a deep convolutional network with multiple convolution stages, each followed by a batch normalization and ReLU activation. The entire code has been referenced in the article linked in the description box below. And here's the protagonist of the story, our generator model, learning to generate images with every passing epoch. The outputs are displayed over 30 epochs for a set of 25 random seeds. Here, each seed is a random 100-dimensional vector that is fed into the generator model. Now, once the generator has mastered the skill of drawing bats, we can analyze how the random inputs that we give to the generator affects its image generation. We can therefore choose any random 100-dimensional input vector and see what the generator produces for that particular input. Here we see two such examples and their corresponding outputs. We can also move from vector to vector and see how the output transforms from one image to another. Google's Quick Draw certainly helped wide international audiences understand how neural networks work. It is a fun way for anyone to interact with a machine learning system, drawing everyday objects like trees and mugs. One of the recent developments in the space of AI and computer vision is text-to-image generation, most notably represented by models like DALL-E and Midjourney. This technology enables the creation of photorealistic images from textual descriptions. There's also an interesting video from Jordan Peele where he demonstrates the power of deep fakes by mimicking former President Obama. Deep fakes are a combination of image to image and speech to speech conversion using AI. This video came out almost 4 years ago, and AI has made phenomenal progress since then. And our project was an effort to understand the fundamentals behind such innovations. Thanks a lot for watching.